Hello guys, welcome to the DMS online school. In today's video we are going to revise science paper 2, the paper which was written on the 9th of August 2023. The paper reads Examinations Council of Zambia, examination for General Certificate of Education Ordinary Level. If you are new to this channel guys, you are most welcome, and on this channel I teach mathematics, biology, science, English, RE, civic education, and also revise past examination papers. So if what I do on this channel is what you're interested in, please consider clicking the red subscribe button below and turn on the bell notification so that when I post a new video, YouTube will notify you. Also, for those interested in online lessons for GCE and also internal grade 12s for next year, please contact me on the number scrolling on the screen. All right, without further ado, let's just go straight into the revision. All right, so this is section A, 20 marks. So section A consists of 20 marks and 20 multiple choice questions, which means that each question carries 1 mark, and on each question you are going to be provided with 4 possible answers from which you are supposed to choose the correct answer. So let's just go straight into it. A1 reads, which of the following is not a branch of chemistry? A, biochemistry, B, organic chemistry, then C, physical chemistry, and D, thermodynamics. Okay, when you look at these answers provided here, of the three of them are actually the branches of chemistry, which is biochemistry, organic chemistry, physical chemistry, but thermodynamics is not a branch of chemistry, so the answer is actually D here. Then A2 says, which of the following statements distinguishes between an atom and an ion? An atom, A, has different numbers of protons and electrons, while an ion has equal number of protons and electrons. No, this is not true. In an atom, you would find that the number of protons and electrons is equal, while in an ion, the number of protons and electrons, they are not equal. So this statement is not true here. B, an atom has no protons, while an ion has protons. This is not true. An atom has actually subatomic particles, which are protons, neutrons, and electrons. So when this says that an atom has no protons, this is not true. Then C, it says an atom is electrically charged while an ion is electrically neutral. This is not true. An atom is not electrically charged. Why? Because it consists of equal number of positive charge and negative charge. You must remember that protons are positively charged while electrons are negatively charged. And in an atom, the number of protons is equal to the number of electrons. This means that the number of charges are equal, the positive and the negative, and this cancels out and renders an atom to have a neutral charge. All right, to be electrically neutral. So this is also not true. Then D is saying an atom is electrically neutral while an ion has an overall electrical charge, which is true. An atom is electrically neutral because the number of protons which are positively charged and the number of electrons which are negatively charged are equal and cancel each other. But in an ion, you'd find that the number of protons and electrons, they are not equal, so there must be an overall charge. So the correct answer is actually D here. We move to question 3A3, which says, which of the following pieces of apparatus can be used to measure accurately a fixed volume of a liquid? Okay, we are looking at apparatus which can be used to measure what? Accurately fixed volume of a liquid. Yeah, when we look at a burette measures accurately volume but not fixed volume. Then B, we look at measuring cylinder, which measures volume but not fixed volume and not accurately. When we look at C, which is pipette measures volume accurately and also it measures fixed volume. So the correct answer should be C here. When we look at separating funnel, a separate funnel is not used for measuring volume, and because of that, it cannot even have this property of measure accurately. Okay, so we move to A4, which says, identify a separation technique which can be used to separate a mixture of water and butanol. All right, so you must understand that butanol is actually alcohol. Alcohol and water are what we call miscible liquids, meaning that when you mix them, they will mix uniformly such that you cannot distinguish them from each other. Now, A method which can be used to separate a mixture of miscible liquids cannot be A, decantation, cannot be B, evaporation, can be C, which is a fractional distillation. So the answer is C, not D, separating funnel. No. So we move to question A5, which says a compound is a chemical combination of two or more elements. Yeah, a compound is a chemical combination of two or more elements. Okay, so the correct answer should be A here, not B, which says a combination of two or more mixtures. Not true. Or C, which says a mixture of two or more elements. No. D, which says a physical combination of two or more elements. Not true. So the correct answer is A. Then A6 says which pair of elements form a compound by sharing electrons. All right, so you must understand that a method which involve forming a compound by sharing of electrons is called covalent bonding. All right, so a process which involves forming a compound by sharing electrons is called covalent bonding, and covalent bonding occurs between two or more nanometers. Okay, so here when they say which pair of electrons form a compound by sharing electrons, so we need to look for 2 nanometers that are sharing electrons to form a compound. So here we have argon and oxygen. Correct, argon is a nanometer and oxygen is a nanometer. However, argon is a noble gases, meaning that it does not take part in bonding because it is already stable. So this A is not the correct answer. B, nitrogen and oxygen. This should be correct because nitrogen is a nanometer and oxygen is a nanometer. So these can combine or can form a compound by sharing electrons. But when we look at C, potassium and iodine, no, potassium is a metal. When you look at D, sodium and chlorine, sodium is a metal. So the correct answer is B. So guys, if you're enjoying this revision, please consider giving this video a like and also let me know in the comment section. If you haven't subscribed, please consider clicking on the red subscribe button below and turn on the bell notification so that YouTube notifies you whenever I post a new video. All right, so let's move to the next question, which is A7. So A7 says an element X forms an ion X with atomic mass 60, proton number or atomic number 27, and a charge of positive 3. Then they're saying what is the number of electrons, neutrons, and protons in this ion. All right, so they've put here electrons, neutrons, and protons. So what you must understand, guys, is that in an ion, the number of protons is not equal to the number of electrons. So in an ion like this one, okay, let me just reverse this situation here. If I were to reverse this situation here, X, I have here 27. If this is an atom, before actually it forms an ion, right? So here the number of protons here should be this one here, 27. Then also the number of electrons should be also 27. Now the number of neutrons should be this here, 60 minus 27, which will be 33. Now in an ion which is like this here, 3 plus, then here 27, then here 60. So the number of protons is still the same here, 27. Then the number of electrons has changed. So for this to form a positive charge of 3, it means it lost 3 electrons. So here it has the 27. Now if 27 loses 3 electrons, it goes to somewhere like 24. That's, oh sorry, so it goes to 24. That is the number of electrons there. So here it is 24. Then the number of neutrons stays the same. Sorry, there. The number of neutrons stays the same, which is 33. So here when they say what is the number of electrons, neutrons, and the protons in this ion, so electrons should be here like 24 like here or like here. Okay, so either this one or this one. Then neutrons should be what, 33. So 33 is here. So and again protons protons should be 27, which is here. So the correct answer here is actually C here. All right, so the correct answer is C. You have seen the way I've answered here. Then A8 says, which of the following is not a characteristic of an acid? Okay, which of the following is not a characteristic of an acid? An acid, A, has a sour taste. Correct. This is a characteristic of an acid. An acid has a sour taste. Then B, produces hydroxide ion when dissolved in water. No, acids do not produce the hydroxide ion. What produces hydroxide ion are actually bases. So this one should be the answer when they say which of the following is not a characteristic of an acid. An acid produces hydroxide ion when dissolved in water. Then we move to the next question, which is A9, which says, which statement explains why salts do not conduct electricity in a solid state of matter? Okay, so A, they're saying the delocalized electrons in salts are not free and not mobile in solid state. This is not true. These salts here, salts do not contain delocalized electrons. This is false. Then B, the ions in salts are not free and not mobile in solid state. Yeah, so there are ions in salts, but those ions in salts are not free and not mobile in solid state. Yeah, that is true. When you have like sodium chloride like this and it is in solid state, it means that these ions which are here, this sodium consists of, actually sodium chloride consists of the sodium ion like that plus the chloride ion like that. Okay, so now these are in solid state here. So they are not able to move, and since they are not able to move, these salts cannot conduct the electricity. So the correct answer is B there. Okay, then we come to A10, which says when strongly heated, calcium carbonate decomposes according to the chemical equation shown. Okay, so you have calcium carbonate when heated decomposes into calcium oxide plus carbon dioxide gas here. Then they're saying, given that 500 grams of calcium carbonate, this one here, were thermally decomposed, calculate the volume of carbon dioxide gas which was produced at RTP. Okay, so they want us to find out how much carbon dioxide volume was produced, or the volume of carbon dioxide which was produced at RTP. So this space is not enough. I am going to answer this question from here. Now, the steps which are involved in answering this question, let me first reverse this. You must understand that you have something like this. You have calcium carbonate like that, which is decomposing now. You are taking it to carbon dioxide because they're saying calculate volume of carbon dioxide. So you were given 500 grams of this, then you are asked to find the volume here. Okay, so you see they have given you something in grams, then they're asking you something in volume of carbon dioxide. So this is the procedure that you are going to find. So move from a mass, which you know, mass of calcium carbonate, then use it to find the mass. You use it to find mass of carbon dioxide. Okay, then use this mass of carbon dioxide you are going to find the number of moles. Okay, to find moles, let me just remove, oh sorry, yeah, I've deleted everything which I was doing, so let me just rewrite it. So I have calcium carbonate like this to carbon dioxide like this. Then here I've been given 500 grams. Then here I'm asked to find the volume, which I don't know. Then I said I must move from a mass of calcium carbonate to mass first of carbon dioxide. Why mass? Because I'm given mass. Then as I move from mass of carbon dioxide, I should now go to moles, okay, of carbon dioxide. Then I will use moles to go to volume, okay, volume of, oh sorry, let me just reverse to volume of carbon dioxide. This is the flow of the steps that we are going to follow. So now let's follow these steps now here. Okay, so the steps are that first of all, this is calcium carbonate to carbon dioxide. So the equation must be balanced first of all. So here we have one atom of calcium, one atom of calcium, one atom of carbon, one atom of carbon, three atoms of hydrogen, oxygen, also three atoms of oxygen. Here we have 2 plus 1, 3. So the equation as it is balanced already. So we are provided what 500 grams of calcium carbonate. So we need to know also what gram of carbon dioxide or what mass of carbon dioxide will be produced. Now for us to be able to do that, we'll use what we call relative formula masses. So here we'll get the relative formula mass of calcium carbonate, which is 100, and the relative formula mass of carbon dioxide, which is 44. Now you might be wondering, where am I getting this from here? You must know that this calcium carbonate like this has got calcium, carbon, and oxygen. Now you need to sum up the relative atomic masses of each element here to come up with the value here. So the relative atomic mass of calcium alone, it is 14, that of carbon it is 20, that of oxygen it is 16. Now you total them up, you say 40 plus this one 12 here, okay, plus 16 here. Now since the oxygen atoms there are 3, so meaning this 16 times 3. Now when you evaluate everything here, you get 100 here, which is this one here. Now for 44 also, you get the sum of the relative atomic masses of each atom here. So carbon dioxide like this, carbon alone is 12, oxygen is 16. So you sum up here, so you are going to have 12 plus 16. Okay, now since here there are 2, you multiply by 2. Then when you sum up here, you are going to have 44, which is this one here. Okay, I hope we are moving together. Now we need to know x here. That is the main aim of doing this. So we are going to cross multiply here. That's what we do. 100 times x, you get 100x equals, then 500 grams times 44, you get 22,000 grams. Then you say, okay, this is equal to this, but we are interested in knowing x here. So you divide by 100, also here by 100, where this will cancel out like that, so that you remain with x here equals, then here it is easy to cancel out like that. 1 into 220, it will be 220, then grams there, meaning this is the mass of carbon dioxide. Now from the mass, we need to find the moles of carbon dioxide. So say number of moles is equal to mass over molar mass. So you substitute number of moles is equal to mass is what you have found here divided by molar mass of carbon dioxide is the same as the relative atomic mass, which is 44 grams per mole. So this one here will cancel with that one. Then you are going to say number of moles is equal to 44 into 220. It will be actually 500 moles. Now that we have found 500 moles, we'll find now volume using this formula here. Number of moles is equal to physical volume over volume at standard conditions, which is the volume at standard condition. So volume at standard condition, RTP volume is always 24 cubic decimeter, if you can check on the periodic table. So that's why in the question they said we find the volume of carbon dioxide produced at RTP. So at RTP, this is the standard volume in 1 mole. 1 mole will give you this. Now you substitute these values here. So you first make this one the subject of the formula because it's the one we are looking for. So V is equal to number of moles times this here, then volume is equal to number of moles, it's this one here, we substitute there times V, it is this one here, 24 cubic decimeter per mole. Then you must understand that this one and this one will cancel, then you multiply 5 times 24, so volume is going to be 120 cubic decimeter. So this will be the volume now. So this is the volume of actually carbon dioxide that was formed. So this is the answer. So here when they said calculate the volume of carbon dioxide gas which was formed at RTP, it is A120 as you have seen. So we move to A11, which says why should water never be added to an acid when diluting a concentrated acid? Okay, so here they're saying The correct answer is actually B. The process of diluting acids is exothermic, and concentrated acids have a high affinity for water. Yeah. So guys, if you're enjoying this revision, please consider giving this video a like if you haven't done so, and consider subscribing to this channel if you haven't done so, and turn on the bell notification, and also let me know in the comment section. For those interested in online lessons for 2024, please contact me on the line scrolling on the screen there, so that you can enter into the online lessons for GCE 2024, also grade 12 internal 2024. All right, so let's continue. So this is A12, which says the following graphs summarize the reaction between powdered calcium carbonate and dilute hydrochloric acid of different concentrations and show the volume of gas produced. Okay, so they're saying that this diagram here actually summarizes the reaction between powdered calcium carbonate and dilute hydrochloric acid of different concentrations, and then show volume of gas produced. Okay, so on the vertical axis we have volume of gas, then on the horizontal axis we have time, and then each of these graph here represents actually the rate of reaction or the volume produced. So we have this reaction one for different concentration of the hydrochloric acid and what calcium carbonate here. All right, then when they say which graph shows the slowest chemical reaction, all right, so you must understand that these the gradient of these graphs here represents the rate of chemical reaction. Okay, so the gradient represents the rate of chemical reaction. So the steeper the gradient, the faster the rate of reaction, and then the less steep the gradient is, then the slower the rate of reaction. Yeah, so like this one here, the gradient is steeper, so reaction one is faster, while for 4 here the gradient is less steep, so reaction 4 is slowest. So when they say which graph shows the slowest chemical reaction, the answer is D there. All right, so let's move. Then we go to A13, which says element X has valence electrons equal to 6. In which group of the periodic table does element X belong? Okay, what you must understand is that the valence electrons here, okay, should be this one here. Valence electrons are electrons in the last shell of an atom. Okay, that's what valence electrons are, and electrons in the last shell of an atom represents the group number in which an element or an atom belong. Okay, so the number of electrons in the last shell also represents the group in which an atom belong. So if this element here has a valence of 6, it means it is in group 6. When they say in which group of the periodic table does element X belong, it is 6 here, so the answer is A. F14 says how are elements on the periodic table arranged? They are arranged according to their not boiling points, mass numbers, melting points, no, according to proton numbers or atomic numbers. So the answer is D. So we move to A15, which says which of the following explains why nanometals are poor conductors of heat and electricity? Okay, so nanometals are poor conductors of heat and electricity because they do not have delocalized electrons. So here when they say A, the electrons in them are localized and not mobile. Yeah, so the electrons are localized, meaning they stay within their shells, and then because they stay within their shells, they are not able to move, they are not mobile or not able to move, so that they can carry charge around. So this is the very reason why nanometals are poor conductors of heat and electricity. So here, without wasting time, the answer is A. So A16 says which of the following is not a property of a typical metal? So A, brittleness. Okay, metals do not have brittleness. This is a property of nanometals. Okay, so these are properties of metals: conduct electricity, ductile, sonorous. So when they say which of the following is not a property of a typical metal, is actually A here, brittleness. Then we move to A17, which says hydrogen can be manufactured from methane according to the following reaction scheme. Okay, so hydrogen gas here can be manufactured from methane according to this reaction scheme. I mean, we have methane plus this substance here acted upon by a catalyst, then hydrogen and another substance P is formed. Then here they're saying what are the identities of substances M, N and P. Okay, here methane and N should be steam here, so it is either steam here, okay, which is reacted with methane. Then N here, it's a catalyst. What catalyst there? It is actually nickel here. Then hydrogen is formed and P is actually carbon dioxide. But here they've said P is oxides of carbon throughout. So carbon dioxide is an oxide of carbon, which is here. So the correct answer then is actually C here. So we move to question 18A, which says which of the following is true about chlorine, bromine and iodine? They are colored. Yeah, which is true. They are colored, these things here. But B, when they say are good conductors of electricity, not true, are non-poisonous, not true, have no smell when in the gas phase, not true. So A19 says which of the following are the products formed in a chemical reaction between an alcohol and a carboxylic acid? Okay, you must know that when an alcohol reacts with a carboxylic acid, the type of a reaction is called esterification, and the product formed mainly it is an ester and water here. So when they say which of the following are the products formed in a chemical reaction between an alcohol and a carboxylic acid, the answer is A here. We move to question 20. A20 says the following structure shows a monomer, a common polymer which has 3 monomer units. Okay, this is a common polymer which has 3 monomer units. This is a monomer, this one is a monomer, and this one. Then they're saying name the monomer for this polymer. Okay, so this is a monomer. So this is actually a starch polymer, this one here, which consists of monomers of glucose. So these monomers are actually glucose there. So we come to section B, 45 marks. So section B carries 45 marks. Then it reads answer all questions in this section. Write your answers in the spaces provided in this paper. Okay, in this question paper. So B1 part 1 says define the term matter. So we are going to say matter is anything which occupies space and has mass. Yeah. Then part 2 of A says give the basic unit of matter contained in carbon dioxide. Okay, so the basic unit of matter which are there are 3. You must understand that we have 1, what we call atoms are the basic unit of matter. Then 2, we have what we call ions. Okay, then 3, we have what we call molecules. Okay, so these are the ones we have. Now atoms are found in things like inert gases or noble gases. Okay, and in things which have not reacted or combined. So in inert gases, even in those elements, noble elements, yeah, noble, I can say noble elements, meaning elements themselves, or I can say in pure elements. Yeah, in pure elements, for instance, that's where you find the atoms there. So then ions are found in compounds which are ionic compounds. Okay, ionic compounds. Then these molecules are found actually in what we call covalent. Oh, sorry, we are moving a little bit where we are supposed not to move. Let me rub this part here. Okay, and then come back here. Now, oh, not here. We are coming where? What is going on here? Okay, so then in molecules you find what we call covalent compounds. Compounds. Oh, sorry, this is not compound. What is going on here? Compounds. So compounds will be like this. Okay, it is raining here. There's some showers. I think you must be hearing some noise, background noise, because of showers here. Yeah, so it might just rain heavily and the video will be cut. If you'll be lucky, if it doesn't go heavy, then I'll continue. So now you must understand that these covalent compounds are formed when two or more nanometers combine. So when you look at this question which says give the basic unit of matter contained in carbon dioxide. So carbon dioxide here consists of carbon and the oxygen, which are nanometers. So the basic unit which are found in covalent compound here, which is carbon dioxide, are molecules. So here the answer is molecules. Then B says state two challenges that have been brought by activities done in chemical industries. Okay, so activities done in chemical industries like in motor vehicle transportation, manufacturing, processing industry, those activities which are there, which uses products of chemistry. The challenges that are brought about by those are the ones they want. So number one is actually air pollution. We are saying air pollution. We are saying combustion of fossil fuels in industrial machines and motor vehicles emits harmful and toxic gases into the atmosphere. So they want to state two challenges, right? Then we'll go to the next one here. The second one is water pollution. We are saying chemical fertilizers and nutrients run off from farms and gardens cause the buildup of toxic algae in rivers. Yeah, so these chemical fertilizers actually are the products of what? Of chemical industrial activities, and then agriculture is actually an industry as well. Yeah, so let's proceed to C, which says explain why it is not advisable for learners to enter the laboratory in the absence of a teacher. All right, so we are saying for safety concerns, because the laboratories often contain various types of equipment and chemicals that can pose serious safety risks if mishandled. Yeah, this is why learners are not supposed to do what? To be alone in the laboratory for safety concerns, because laboratories often contain various types of equipment and chemicals that can pose serious safety risks if mishandled by the learners. Okay, then another one we can suggest is that the learners may not have the necessary skills or knowledge to use the laboratory materials or procedures correctly or safely. Okay, so it appears like heavy rains have started, therefore I'm cutting the video. So the rains are gone, so we continue. So B2 says use the knowledge of the kinetic theory of matter to answer the questions that follow. A, explain why an inflated balloon which is placed in a refrigerator slowly starts to shrink and reduce in volume. Okay, so according to the kinetic theory, now we are saying when an inflated balloon is placed in a refrigerator, the temperature of the air inside the balloon decreases. This means that the air particles inside the balloon move slower and collide less frequently and with less force. This reduces the pressure of the air inside the balloon. As the pressure of the air inside the balloon decreases, the balloon shrinks and reduces in volume. Okay. Then we move to B, which says with reference to energy changes, what type of process takes place in A? So here we are going to say the process that takes place in the above process is an exothermic process. This means that the process releases energy to the surroundings as heat. Then C says explain why wet clothes dry faster on a warmer day than on a colder day. Okay, so here we are going to say on a warmer day, temperature is higher and this increases the kinetic energy of the particles in a liquid on the cloth. This increases the rate of evaporation and in turn clothes dry faster than on a cold day where temperature is low and the rate of evaporation is slow. Okay, we move to B3, which says the experimental setup that follows shows a mixture of sand and iodine crystals in an evaporating dish. Okay, in this experimental setup here, we have an evaporating dish here, and also inside it we have a mixture of sand and iodine crystals here. Okay, then they're saying A, describe how the mixture of sand and the iodine crystals can appropriately be separated. Okay, so you must understand that iodine sublimates while sand does not. So the method which can be used to separate this is actually sublimation. So here when they say describe how the mixture of sand and iodine crystals can appropriately be separated, you can say that a mixture of sand and iodine crystals can be appropriately separated by heating the mixture so that iodine crystals sublimizes and the sand is left behind on an evaporating dish. Then B says explain why bottled minerals water, explain why bottled mineral water is not pure water. Okay, so the answer says bottled mineral water is not pure water because it is a mixture of water and dissolved minerals and other substances. Okay, we move to the next question. C says give one criteria for purity of a substance. Okay, so here you need to give the things or characteristics that we use to determine whether a substance is pure or not. So we are saying N of these: boiling point, melting point, freezing point, chromatograph, density, or refractive index. These are criteria of purity or are properties of substances that we use to determine if a substance is pure or not. Then B4A says figure 4.1 shows an electronic structure of element Q. Okay, this is element Q, this is the electronic structure. Then they're saying part 1, name element Q. Okay, so for you to know what element it is, this one here, you need to know the number of electrons it has. Okay, so it has 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17. So if an atom or an element has 17 electrons, it means it has also atomic number 17. And if you check from the periodic table, an element which has 17 as atomic number is actually chlorine. So when they say name element Q, it is actually chlorine. We proceed. So here part 2 says state the periodic the period of the periodic table where element Q belongs. Explain your answer. So this one belongs to period 3. Why? Because the number of shells, or the period in which an element is found, is equal to the number of shells it has. So when you look at this element here, it has shell 1, shell 2, and shell 3. So it has 3 shells. So the number of shells equals to the period in which the element belongs. So here when they say state the period of the periodic table where element Q belongs, explain your answer. You say that chlorine belongs to period 3 because it has 3 shells, since the number of shells determines the period. Okay, we move to part 3 where it says explain how an atom of element Q acquires chemical stability. Okay, so that element, as we have seen, it is not stable. It does not have 8 electrons in the last shell, so it should gain electrons for it to be stable. So what we use to determine whether an element will gain or lose is this actually property where we say, or this concept where we say almost filled up electrons or almost filled up shells gain electrons, while almost empty shells lose electrons. So when you look at that chlorine atom, the electronic structure there, the last shell had 7 electrons, so it was almost full, and since it is almost full, it should gain only 1 electron. So in answering this question, we are going to say by gaining 1 electron or sharing 1 electron. Why have I put 2? Because since chlorine is a nanometal, it can become chemically stable either by gaining 1 electron or by sharing that 1 electron, because nanometals involve themselves in two kinds of bonding, which is ionic bonding and also covalent bonding. So B, they're saying explain what you understand by the term nucleon number. All right, simple. So you should say that nucleon number is the sum of the total number of protons and neutrons in an atom. Yeah, then B5A says distinguish between an acid and a base. So here you can say an acid produces ions. An acid produces, okay, you say acids produces hydrogen ions in aqueous C state as the only positively charged ion, while bases produce hydroxide ions in aqueous state as the only negatively charged ions. Yeah. So also bases, if you want, you can say acids have sour taste while bases have bitter taste. Then you can say acid 10 blue litmus paper red, while you can also say bases 10 red litmus paper blue. Then you can also say that acids have a pH which is less than 7, while bases have got a pH greater than 7. Those are the ways in which you can distinguish bases from acids. Okay, we proceed. Then B says explain what you understand by the term salt. So we define a salt as follows. Same. A salt is a compound formed when the hydrogen ion of an acid is fully or partially replaced by a metal or ammonium ion. So yeah, so when they say explain what you understand by the term salt, it is just as good as asking you to define salt. So they can say define a salt or explain what is meant or what you understand by the term salt. So you give a definition. A salt is a compound formed when the hydrogen ion of an acid is fully or partially replaced by a metal or ammonium ion. Okay, we move. Then B6A says define the term mole. Also, define the term mole. Here you are going to say a mole is an amount of a substance which contains as many elemental particles as there are carbon atoms in a 12 gram of carbon 12 isotope. Yeah, this is the standard definition of a mole. If you want, you can say a mole is an amount of a substance that contains 6.0.6. Okay, a mole is an amount of a substance which contains here 6.022 times 10 to the power 23 elementary particles. That one also can qualify to be the definition of a mole. Then B says the concentration of sodium hydroxide solution is 0.25 mole per cubic decimeter. Calculate the number of moles of 0.25 mole per cubic decimeter of sodium hydroxide solution contained in 250 cubic centimeters of this solution. Okay, so you must understand that this question actually is asking you to find the number of moles. Okay, that's what it is asking you to do. Well, they have given you what? Concentration and the volume here. So the number of moles is found using this formula, which says concentration is equal to number of moles over volume. Why using this formula? Because you are looking at what you are given. You have been given concentration, you have been given volume, and then they're asking you to find number of moles. So this is the formula you use. Then you say number of moles, you make the subject of the formula number of moles, because that's what you are looking for here. Number of moles is equal to concentration times volume here. Then you start substituting. Concentration is this one here, 0.25 mole per cubic decimeter, then it times volume. Volume, actually this one you are given is they've given you volume of 250 centimeter cubed, but the volume should be in a decimeter here. So you convert it by dividing with 1000 so that it goes to 0.25 cubic decimeter. That will be the volume you are going to use here. So you use volume here, the one you have converted here, which is 0.25 cubic decimeter. Then you say equals number of moles equals, so you see that this one here and this one will cancel. So when you multiply, you find the answer will be 0.0625 mole. So this will be the answer. Then we move to the next question, C. So C says iron metal is extracted iron metal is extracted from an iron ore called hematite in a blast furnace during a reduction reaction using carbon monoxide gas as a reducing agent as shown in the following chemical equation. Okay, so this is hematite, here iron 3 oxide reacted with carbon monoxide to form iron and the carbon dioxide. So this is a balanced equation here. Then they're saying calculate the mass of carbon monoxide gas required to reduce 3,200 kg of iron 3 oxide in the blast furnace. Okay, so here they've given you this one here. Let me just remove this first. No, it's not like that. So they've given you here, they've said they have given you okay, this is what they've given you, which is in 3,200 kg of iron. Then they're asking you how much was required of this. So you don't know, you put X. So now you do the equation, you write. So what you have been given to what you are looking for. So you have this and this. These are the things you are dealing with. So you say you have been given 3,200 kg here. Then you don't know the mass, what it should be, because the question says calculate the mass. So you don't know what the mass of carbon monoxide it is going to be. So you use a balanced chemical equation. So in this case, it will be simple. Since you have been given mass, to find the mass it will be easy. You use the molar masses here, or the relative atomic mass of iron 3 oxide, which will be 160, equals the relative atomic mass here to be 84. Now here iron alone, you see iron like this. Okay, here iron alone should be 56 if you're not mistaken. Then oxygen is 16. Okay, then if you total everything, you find that here you say 56 times 2, then plus, then 16 here times 3, because there are 3. If you total everything, if I've not made a mistake, you'll find that this is going to be 160. Okay, then for carbon monoxide you carry with 3 itself here. Since you are dealing with an equation, so you carry with 3. So say 3CO. So carbon alone is 12, oxygen is 16. So you say equals, you say 2 times, open brackets, you say oh, this is not 2, I'm using 3 here. So let me just say that you say like this 3 here, open brackets, then you say 12 plus 16. So when you evaluate everything here, you are going to find that this one is going to be 3. Inside here you have this plus that 8, then this plus that, it is going to be 2. Okay, then let me see, this times that, it will be 24 carry 2. This times that, it will be 6 plus 2, 24 carry 2. This times that, 24 carry 2. This times that, it will be actually 6 plus 2, 8. So 84. This is how this was found there. Okay, so now you cross multiply. So you say 160 times x is 160x, then 3,200 times 84, you get 26,800, 266,800. So you're looking for x, so divide by 160, also by 160. So here this one is going to cancel this one here, then here you remain with x. Okay, so you remain with x there. Let me just clear there. X is equal to this one into there, it will be 160 or 1,680 kg. So this will be the mass of now. Yeah, so you say 1,680 kg is the mass of carbon monoxide required. Yeah, then we move to the next question. B7 says describe how the action of heat on the carbonate of a metal depends on the position of the metal in the reactivity series. Yeah, here you say the higher the metal is in the reactivity series, the more stable its compound is to heat. This means that the carbonate of a more reactive metal requires more heat to decompose than the carbonate of a less reactive metal. Then B, transition metals and their compounds can be used as catalysts. Okay, then part 1 of B says explain what is meant by the term catalyst. Okay, so here a catalyst is a substance which changes the rate of chemical reaction without itself undergoing any permanent chemical change. Then part 2 of B says explain why metals are good conductors of electricity and heat. So the answer says metals are good conductors of heat and electricity because they have delocalized electrons which are free and mobile to carry heat and electrical energy through the metal. Yeah. We move to the B8, which says greenhouse gases are given greenhouse factor values. The greenhouse effect of a gas increases with the factor value. The following table 8.1 gives information on 4 different gases. Okay, so we have 1, 2, 3, 4 gases, greenhouse gases, carbon dioxide here with a greenhouse factor of 1, percentage of gas in the atmosphere 0.036, then 2, methane, this the formula, greenhouse factor is 30, percentage of the gas in the atmosphere is 0.0017, then 3, dinitrogen oxide, which is this, the greenhouse factor is 160 and this is its percentage, and also 4 is carbon trichlorofluoride, and this is its greenhouse factor and this is its percentage in the atmosphere. Then A says identify the gas which has the greatest effect on the environment. Give a reason for your answer. Okay, so carbon trichlorofluoride, this one here is the one. Okay, carbon trichlorofluoride, this one, because it has largest greenhouse factor of 2100 or 21,000, since the greenhouse effects increases with the factor value. Okay, then we go to B. Why is an increase in the percentage of methane more worrying than the same percentage increase of carbon dioxide? We are saying this is because methane has a much higher greenhouse factor of 30 than carbon dioxide, which has a greenhouse factor of 1, which is much less if you check there. Then C, what other environmental problem besides its action as a greenhouse gas is caused by carbon trichlorofluoride? Okay, we are saying the depletion of ozone layer, which act as a protective layer against harmful rays which can cause skin cancer or cataract of the eye. Okay, we move to B9, which says alkanes form a homologous series of organic compounds which are also called paraffins. Then A part 1 says state the general molecular formula to which the alkanes conform. So this is the general formula to which the alkanes conform. Then part 2 says draw the displayed structural formula of pentane. So pentane is an alkane with number of carbon atom equal to somewhere 5 there. So this is the structural formula of pentane here, 4 carbon atoms. So it's easy. If you know this formula here, you can, and know that pent means 5, so you can derive the formula actually here, where you say the general formula is C, where there's N there you put 5. Okay, then you say H, you put H there, then you put 2 there, then times, where there's N there also you put 5, then plus, then 2 there. Okay, so this goes to, so C5, it will be now 2 times C5, 10 plus 2, 12. So H, 12 there. Okay, so now this is how it is going to be. So now to draw the structural formula now, like this one here, you just scatter out the carbon to the carbons, like 1, 2, 3, 4, 5. Then each carbon should be surrounded by 4 bonds. So you start writing 4 bonds like that around that one, like that. So now you distribute these 12 hydrogen atoms remaining, so you put them like that, as simple as that. Okay, so this is how this should be done. Okay, so this is how we found that one as the answer. Okay, now we proceed to the next question. Okay, so sorry, let me get this one. So here B says give 2 reasons why cracking of large hydrocarbons is important. Give 2 reasons why cracking of large hydrocarbons is important. Okay, number 1 is that cracking helps to match the supply and the demand of different fractions of crude oil such as gasoline, diesel, and kerosene. Yeah, so cracking helps to match the supply and the demand of different fractions of crude oil, such as gasoline, diesel, and kerosene. What this means here is this. You'd find that the use of small fractions is high. Small fractions such as the gasoline, diesel, and kerosene are on high demand, and because of being high demand, the supply and the demand must be matched. Okay, so to do that, you need to crack those long chain hydrocarbons or large hydrocarbons, so that when they're cracked or broken down to smaller chains like gasoline, diesel, and kerosene, then the supply of these will be made available. Then 2 is that cracking also produces alkenes that are used as feedstock for the petrochemical industry, which makes plastics, synthetic rubber, and other products. Then C, justify why alkenes are sometimes called paraffins. So we are saying because they are chemically unreactive. Yeah, so alkenes are called paraffins because they are chemically unreactive. Now let me give you more explanation here. Here we are saying paraffin. This word paraffin comes from the Latin word param. This one here meaning little, and affins. This last one here meaning affinity. So which refers to the low reactivity of alkenes. So paraffin in totality refers to the low reactivity of alkenes. Okay, now alkenes are relatively inert and do not undergo many chemical reactions except for combustion and substitution with halogen. So therefore, they have little affinity for other substances and are called paraffins. Yeah, so yeah, that's why they're called paraffins. Now we move to section C, 20 marks. Then here they're saying answer any 2 questions from this section in the separate answer booklet provided. Yeah, so you'll be provided with a separate answer booklet, and from that answer booklet is where you are going to put your answers, and you need to label the answers very well. Okay, your answers must be labeled correctly. Okay, so that when you label them correctly, then that one is going to carry more weight. Okay, I mean, it will enable the examiner to see which question you have answered and mark you accordingly. Okay, so you need to answer only 2 on the separate answer booklet. They will provide you. You label C1, then you put A, you answer B, you answer D, you answer like that. Okay, so let's read. It says, okay, yeah, it comes to this. So we'll read everything. So the scale in a kettle contains calcium carbonate, and the aminosulfonic acid is used to remove this scale. This acid reacts with the scale and produces a gas. So they're saying the apparatus in figure C1.1 was used to collect the gas formed when excess acid was added to small amounts of the scale. Okay, so this is the apparatus. So test tube, this is the scale. Dilute aminosulfonic acid was put there. Then these are bubbles which we are seeing there, and this will be collected here in the gas syringe. This is a plunger and this is a plunger. This is the gas will come here when it comes from there. Then part 1 says, they're saying, how could you tell that a gas is being produced? Then part 2 says, name the gas produced. Then part 3 says, describe a chemical test for the gas. Then B says, a learner measured the total volume of a gas produced over 120 seconds. His results are shown in table C1.1. Okay, so this is the time from 0 to 120. This is the total volume of gas measured from 0 to 65 there. Then part 1 says plot a graph of the results, which is volume against the time on the graph paper provided. Then part 2 says circle the point which seems to be incorrect. Then part 3 says calculate the average rate of this reaction. Okay, so let's start answering this one here. So I will be answering this one with the question. So let's start with the first question here. Let me come where? Here. Okay. So this is the first question here, which we must deal with first. So this first question is saying, how could you tell that a gas is being produced? So to answer this question, you say C1, you're saying part 1, that's how you go. Same by observing the formation of bubbles in the liquid. Yeah, so like the bubbles in the liquid here would show that the gas is being formed. Then part 2 says name the gas produced. So you are saying if the scale in a kettle contains calcium carbonate and let me just reverse here. So in this there's calcium carbonate here. So this calcium carbonate we are talking about here, when you react it with an acid, we don't mind the name of an acid, it doesn't matter. We should know that what will be formed is the carbon dioxide gas. So when they say name the gas produced, it will be carbon dioxide gas here. So we will say part 2. Okay, we had two options here. We say by observing the movements of the plunger as the gas fills the gas syringe here. So I provided two answers here in that how can we tell that the gas is being produced? I said by observing the gas or by looking at the plunger. If this plunger moves outward, meaning it will show that the gas is filling up this space. Yeah, now when they say name the gas produced, I said this is carbon dioxide gas. Okay, so carbon dioxide gas. And when we come back to this, describe a chemical test for the gas produced, like what is the chemical test for carbon dioxide? So we're going to say that the gas is bubbled through lime water. Lime water turns milky or white PPT formed, or a white PPT is formed in lime water. Yeah, so this is the identity test. Then we go to the next question here which says B, we plot a graph of the results, which is volume against time on the graph paper provided. So you'll be given a graph paper. So we go to B here. You should write CB1 where you need the graph paper like this. So we'll label the vertical axis and then the horizontal axis. So this one will be volume, vertical axis. Okay, how do you tell that which one will be which one? So you come here, when they say plot a graph of results, volume against time. So what comes first? Volume. It means it will be on the vertical axis. Time will be on the horizontal axis. This is how the order has been put: volume vertical, time horizontal axis, or volume y-axis, time x-axis. Always when they give you the order like this, the first one is for the y-axis, the second one is for the x-axis. Yeah, so this is how we are going to plot. So this is volume in your label in cubic centimeters and the time in seconds. Then what follows next is the what? Okay, the scale. So now you need now to label these with numbers, the vertical axis and the horizontal axis. Now you need first to bring the values which were provided. Okay, so I've brought the values which I was provided with. So when you look at volume, the highest value is 65. Okay, this 65 here, because people talk much of the scale. You remember the scale does not have marks. In an exam, what has marks are these and this here, and then the title has got marks, and the way you plot the graph. The scale does not have marks, but it's very important that you know. So in determining how you are going to label the axis here, you look at for volume, the highest you have is 75. So you ensure that the values that you are going to put here on the vertical axis, they should go beyond 75. Okay, so that 75 can be accommodated. And also on the time here on the horizontal axis, the largest value is 120. So you make sure that you put the numbers here that will make sure that it will swallow the 120. So you see, so this is what you do. So since we are starting from 0, this point here will be 0 there. Okay, then since I'll start with this one here, so I'm going to 120. So for me to accommodate 120, I'll look at what I have these lines here. So I can just put this one of equal intervals. If I say this is 1, 0, I say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'll fail to reach 120. So if I say, okay, if I say 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120. At least I have reached 120, which is good. This is how we decide it. So in terms of the scale, you can say that on the x-axis, like x-axis, you are saying from here, from 0 to 10, this capox represents actually 2 centimeters. So you say 2 centimeters is giving you 10 units. From 0 to 10 here, there are 10 units. So you say 10 units. Then you are done here. That's how we do it. Okay. Then you come on volume here, the highest is 75. So if you count again 1, 2, 3, 4, 5, 6, 7, 8, you'll not reach 75. But if you say 10, 20, 30, 40, 50, 60, 70, 80, 75 will be in the middle there. So you'll be able to accommodate 75. So that's why you decide to say, okay, this will be 10, 20, 30, 40, 50, 60, 70. There, if you want, you can put 8. I think I didn't put 8 there. Now, you also say now on the y-axis, you say the same, like from here to here, it is actually 2 centimeters. So you say also here 2 centimeters equivalent to 10 units. Yeah. If you want, you can put that one for the sake of argument. Then after you do that, you can label your graph volume against time, because the mark, this one should have a mark, this one a mark, this one a mark. And also the way you are going to plot your graph will determine, will also give you some marks there, or make you attain some marks. Okay. Then now you start plotting. So you start plotting like here you start plotting 0, 0, it's here. So you put a point there, a dot. Then here you come to 5, 20. So only the time 5 is on the middle here. So this is 0, this is 10. So 0, 1, 2, 3, 4, 5 here, 20. You come somewhere here, you put a dot here, because 0, 5, 20. Then here 20, 40. So 20 is here, you go up to 40 there. Okay. Then here 35, 50. So this is 30, 31, 32, 33, 34, 35, comma 50 somewhere there. Okay, then you come to 55 comma 60. So 50 is here, 55 is here, comma 60 somewhere there, because this is where 60 is, so somewhere there. That's how we plot. Then here 70 comma 75, so 70 is here, 70 is here, so 70 is here, so you calculate 70, 71, 72, 73, 74, 75 there. Then here 90 comma 65, so 90 is here, 65, this is 60, so 90, you say 90, this is 60, 61, 62, 63, 64, 65, you put there. Then this is now 120 comma 65, so 120 is here, 65 again on the same line there. Then you draw a smooth line that should pass through all the points. Now this point is awkward because the curve should go like this. This is how the curve goes. You draw it like that without using a ruler. Okay, then we come here, they're saying part 2, circle the point which seems to be incorrect. So we will circle now on our graph the point which seem not to be correct. This one here, this one, we circle it like that. Okay, then next they're saying calculate the average rate of this reaction. So we'll calculate now. Here we'll come here, we reached here. Now many students ask me, like, should you answer the question on the graph paper? There are certain questions that you can answer on the graph paper, like this one, it is on the graph paper like this. Some you cannot even put them on the graph paper. What is important in science is labeling. You need to label. Like when I started answering, like here, so you see this is C1, you start labeling it as you are putting answers. Then as you pack your papers for submission, the graph paper should be put next to where you have answered this part C1. You put them together so that the marker will be able to find the graph paper and see the other questions you have answered on C1. That's how it goes. So in mathematics, it's where they say answer these questions on a graph paper. In science, we don't command you that. It depends. If a question says answer on a graph paper, then you can answer. But in most cases, it doesn't say so. And failure to answer from the graph paper does not equal penalty. You cannot be penalized. Okay, as long as you have labeled your answers like we have labeled here, and you have put the graph next to your answers, then the marker will see your answer on the graph paper and other answers on the same part. Now here we are trying to answer this, which says calculate the average rate of this reaction. So here we'll label this is B. You see how we are doing it. This is actually I never, this is B3. Yeah, you label it as B3. So this is B3. That's how you go. So rate of chemical reaction is equal to total volume over total time. So meaning total volume over total time. So if you check from the graph there, the total volume was actually 120. Okay, so I didn't manage my thing properly, so let me try to manage it so that I assist you in doing this. Okay, so I've done this so that you can see properly. So here, when you look at the volume, when the graph goes up like that, it means volume and was increasing with time. But here where it goes horizontal, it means that volume stops increasing as time was moving. At somewhere 90 seconds here, the volume stayed at 60 and this is 60. Okay, when you check, this is at 65 up to somewhere there. So this is the maximum volume which was produced. You can also notice from here, total volume The highest volume is this one here, 65. This is the point we have discarded here, which was wrong according to here where they said circle the point which seems to be incorrect. So we discarded this one. So the highest volume which was produced is here. Then the time that was spent is 90 here. This is not the one because the maximum volume was reached here on the first time, which elapsed 90 here. So here 65 120, don't use this one. 65 meaning the first time here is what you use. So in answering this one, that's why I said you use total volume over total time. So you say rate is equal to total volume 65, total time is 90. So you put the units, then you say rate is equal to 65 divided by 90. You have like 0.72 cubic centimeters per second as the answer here. Okay, then we move to the next question. C2. Zinc blende is one of the ores of zinc metal. Then state the chemical name of zinc blende. Then B, describe how zinc metal is extracted from zinc blende, include the necessary balanced chemical equations. Then C, state two uses of zinc metal. Then D, suggest one environmental problem that is a consequence of extraction of metals. Okay, so we move here to the solutions. So since here the question says state the chemical name of zinc blende, so here in answering you say C2A, so zinc sulfide, this is the chemical name of zinc blende. Then the next question says B, describe how zinc metal is extracted from zinc blende, include the necessary balanced chemical equation. So this is how you answer. So say B, say zinc metal is extracted from zinc blende by first roasting the ore to convert it to zinc oxide. The zinc oxide is then reduced with carbon to form zinc metal. The following are the chemical reactions which takes place. So you write this one. Zinc blende, which is zinc sulfide. First, it is roasted in oxygen to produce zinc oxide and sulfur dioxide. You balance the equations like that. Then another equation now is this. Zinc oxide now reacts with carbon to form zinc metal, which usually is in gaseous state, plus carbon monoxide. So this equation is balanced as it is. So you have answered this part here. Then you come to this one which says state two uses of zinc metal. Okay, so C, uses of zinc metal. Say zinc metal has a wide range of uses, including, so here I had to put a lot, so you can choose from these. So in galvanizing, so zinc metal is used to coat iron and steel to protect them from corrosion. Then brass and bronze alloys, so zinc metal is alloyed with copper to produce brass and bronze, which are strong and durable materials. Then also in batteries, zinc metal is used in dry cell batteries. Also in roofing, zinc metal is used to make roofing materials. Also pharmaceuticals, zinc metal is used in some pharmaceutical products such as zinc lozenges and zinc ointments. Yeah, so we go to the next question here. Suggest one environmental problem that is a consequence of extraction of metals. Okay, so the answer which I gave here was specifically for zinc. This is when I've realized that for extraction of metals, meaning they wanted those which are general. However, even these ones I gave can apply here. So here we can say that one environmental problem that is associated with extraction of metals is air pollution. Okay, so metals, when they're extracted, air pollution is one of the consequences of it, or environmental problem. So the roasting of metal ores produces sulfur dioxide. In this case, we are talking of zinc, which is a harmful gas that can contribute to acid rain. So in addition to air pollution, other environmental problems associated with metal extraction include water pollution. Okay, so mining mining and processing of metals can generate waste water that contains heavy metals and other pollutants. This wastewater can contaminate rivers, lakes, and underground water. Also, land pollution. Mining activities can disturb the land and leave behind waste products that can contaminate the soil. Also, deforestation. Mining operations can lead to deforestation, which can harm ecosystems and contribute to climate change. Yeah, so we have answered C2. Then we come to C3, which says ethane and ethene are both organic compounds. A, compare how they react, if at all, with part 1 oxygen gas, part 2 hydrogen gas. Then part 3, write a chemical equation for any of the reactions in part 1 or part 2. Then B, draw the displayed structural formula of part 1 ethane, part 2 ethene. Then E, describe a chemical test that can be carried out to distinguish ethane from ethene. Okay, so this is what we answer here, how we answer. So the first one we are looking at, we do what? Compare how they react if at all with part 1 oxygen, part 2 hydrogen, part 3 the chemical reaction. So we are looking at ethene and ethane and ethene here. Okay, so here we are going to say CA1, we are going to say ethane and ethene both react with oxygen gas to produce carbon dioxide and water. This is called complete combustion. Okay, then part 2 here, also with hydrogen, we are going to say ethane does not react with hydrogen gas under normal conditions. Ethene reacts with hydrogen gas in the presence of a nickel catalyst to form ethane. Okay, then this other part 3 here says write a chemical equation for any of the reactions in part 1 or 2 there. So here we'll write the reaction, like here this is ethene plus hydrogen, which is giving us actually this is actually ethane with oxygen, which is giving us carbon dioxide and water. So we can balance it like that. Then also we can write ethene also with the oxygen gives us carbon dioxide plus water, and we can balance it like that. Okay, so these are the equations. Then we come to the other question, which is B, draw the displayed structural formula of ethane and ethene. So this will be simple, right? So eth means 2 carbon atoms. Okay, so eth means, okay, let me come here. Here it will not work. We had other chemical reaction. Okay, this is the reaction of ethene with hydrogen to form nickel catalyst to form this. Now to form methane. Now we look at B, where we want to draw the structural formula for this one here, ethane, right? So ethane, eth means N is equal to 2. Okay, so now, okay, the formulas are already there. Okay, so this is for ethane, so you just write like C, you do like this. Then since there are 6 hydrogen, so you surround each one of this carbon with 4 bonds. These lines, they represent bonds. So here you put 1 2 1 2 3 here, so 3 here, also here 3, like that. Yeah, I think this is simple. So this is it. So for ethane, this is what I had to write. For ethene, this is what I had to write. Ethene is this one here, so it has a double bond there. Okay, then we move to the next question, which was C there. So C, what was here, it says, in fact it was A, B, C. They made a mistake. Instead of saying C, they had to write E there. So they're saying describe a chemical test that can be carried out to distinguish ethane from ethene. Okay, so this is the chemical test. We are saying to perform the bromine test, place a small sample of the gas in a test tube and add a few drops of bromine water. If the gas is ethene, the bromine water will turn colorless. If the gas is ethane, the bromine water will remain reddish brown. Yeah, so this is the test. So in this sentence, the sentence did not flow very well, but you can say a bromine test is carried out to test for the for ethane and ethane, and then you say to perform the bromine test, place a small sample of the gas in a test tube and add a few drops of bromine water. If the gas is ethane, the bromine water will turn colorless. If the gas is ethane, the bromine water will remain reddish brown. Okay, so we have come to the end of the chemistry revision. If you have enjoyed it, give it a like and let me know also in the comment section. Also, for those interested in online lessons, you can actually look at you can contact me on the line on the screen there so that you can join the online lessons. As for now, guys, bye and see you in other videos.